Okay, welcome to the third lesson. So this lesson we will talk about more on triangle and how to plot the graph of conic, like the circle or ellipse. And before that, we're gonna add something on. Let's say I define my x. This class I will learn on how to expand a function into polynomial. Let's say times. Let's say I define one function to expand it, this bracket, and we got the expand. And right now we need to transform this thing back to something in a factor. So I have the thing which is called using the command which is factor. Okay, simply I can use factor my answer. So I can have factor of 512 x minus 1 x squared plus x is one of factor, x plus 1 and x plus 1. Okay. If I want to make it nicer, so I can PORT means product of answer, means I need to times all the factor out. So I can get back something like this. So a nice looking. So when I expand this, I should get something back into like this one. So this should be a very nice thing to make it. Okay. And next thing, if I have numerator and denominator, then we should make it nicer. Let's say I have an expression which is equal to 1 over x plus 4 minus 2 and divided by x squared minus 2 times x plus 1. This. Okay. And then I need to pick this thing show it into the numerator and denominator. You can write like this, a square bracket, and then n, comma d. And n stands for numerator, and d stands for denominator, and because I need to put the expression okay, equal to num that means numerator and denominator of expression. So you can see I can make it, this is a numerator and this is the denominator. This is how I define them. And this is the command. Okay, if I want to look nicer, I can say pretty. So we look like this. X plus 4, x squared minus 2 x plus 4. Okay, cool. And next, we're going to go on inverse of trigonometric function. So like how we have like arc sine, or simply means like the sine power of -1. So we have a simple thing which is just put the A sine means arc sine. So A tan means arc tangent. And that's just like that. We do the arc sine and arc tangent. This is very straightforward. Okay. And let's say right now we need to draw or we plot out the circle given an equation. Let's say, okay, office. Let's say I define my symbol, x and y. I have an equation which is equal to x squared plus 4x times y plus 5 times y squared plus 4x minus 6 equals 0. So we have x squared It's y squared is something like a circle or an ellipse. So I have my equation. Then next I need to plot it out. We use f implicit and equation. Before this we plot is like we plot a function is f plot. So here I f implicit, we plot something like a circle or an ellipse. Let's try. As you can see now, this is over big. We cannot make it nicer. So means we have to set our range. So to make it a nice looking ellipse. So let me set it into the function more than -5. So I say equation, the range. So I give my, this is my x, -23. This is my axis, and next is the y-axis from -3 to 10. Okay, so the x-axis is -5 to 3, y-axis is -3 to 10. Bracket. And look at it again. Right now it should look very nice because I set the range from -25 to 3 and -3 to 10. So it looks nicer. Okay. Okay, and next let us draw another function. Let's say another function which is called, which is square over 9 plus y squared 16 is equal to 1. So this is something like a hyperbola function. So I have mistyped it, so it should be, it should be square. Okay, and then I'm going to draw this out as implicit. Okay, and see how it looks like. So it looks like this. Right now, since it's hyperbola function, I need to add the asymptote. If you know what is an asymptote, means the line that define that they never touch each other. Something like this until here and until here. So in order to find that, if based on the max itself, the function just now we have, which is like x squared over 9 minus y squared over 16 is equal to 1. So in order to find the asymptote, it just simply this the 9 squared become 3 squared and 4 squared. Okay, the asymptote is simply just this one over this one, 4 over 3. And we got 2 plus minus. And this is how we get the asymptote. And for the asymptote, we need to draw like the dotted line. Okay, let's say I want to have one green color, another one in red color. So let's try it out. So I will say hold on because I need to plot another function. See, hold on. Okay, f plot symbol function bracket 4 over 3 times x dot x. This is the function of x dot, and because I want to draw a dotted line, so I say dot dot green. Okay, it's one of it. And then the second line, same thing, function, but it's in negative. 4 over 3 times x rebel dot dot, let's say red. Okay, so you see right now I've drawn my asymptote. One is in green and one is in y. So it looks nice. Okay, so next we're going to look about transferring a function in terms of other variable. Okay, let's see how we're going to do it. Let's say if you know like the hyperbolic function, like the sine x. Sine x actually should be like exponential x over 2 or exponential negative x over 2 instead of writing sine x. So I need to write the sine x in terms of exponential. So I will use this command, say rewrite. Of course, I need to define my variable x first. Rewrite sine x, okay, comma. So the thing I want to write in terms of, this is my function into exponential. But I cannot write simply put exponential, I cannot put comma, comma. So equal. So as you can see right now is exponential x over 2 minus negative exponential minus negative exponential negative x over 2 is in like this. Ex minus e negative x 2. So this is equal to the sine x. So that's how we express this thing in terms of exponential. Okay. So let's try, let's say I need to rewrite my arc, and this is also another hyperbolic function, which is arctangent 3 over 4. If I want to make it nicer, I would say sim, because this is in exact solution, 3 over 4, bracket, bracket, comma, in terms of log right now. Then we got this in terms of like this. And this is how we transform from one function into another form. Okay, so that's it for today's lesson.